Hello viewers, you're welcome to the maiden edition of our YouTube video. Today I'm going to be solving a problem under the topic differential calculus, and the problem is find the derivative of f of x equals x to the power of 2 from first principle. Now I'm going to show you the formula I intend using, and the formula is f prime of x equals limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Now I'll explain the terms of this formula. F prime of x signifies the first derivative of this question. Delta x signifies small increment in x, and you can see x is reflecting both from the left and the right hand side of this question. So if we're able to get an expression for f of x plus delta x minus f of x divided by delta x, we'll reduce it to the simplest form, and then we'll find the limit as delta x approaches 0. So the final answer equals the derivative of this function from first principle. So I'll write out my question. F of x equals x to the power of 2. I'll christen this equation 1, and then I have f of x plus delta x, where delta x signifies small increment in x, equals, we open a bracket, x plus delta x all to the power of 2. So I need to expand the right hand side of this equation. So I have to expand the right hand side. I pick it one after the other. X times x is x to the power of 2 plus 2 times x times delta x. Plus times plus is plus. Delta x times delta x is delta x to the power of 2. So we've expanded the right hand side of this equation, and that gave us this. So I can christen this equation 2, and then I subtract equation 1 from equation 2. So left hand side of equation 2 minus left hand side of equation 1 equals right hand side of equation 2 minus the right hand side of equation 1. So we can see x square is reflecting in two places. So I can say x square minus x square, that gives me 0. And so this equation boils down to 2x delta x plus delta x to the power of 2. So I need to divide through. When I say divide through, I mean dividing the left hand side of this equation by a factor and the right hand side by a factor, and that value is delta x. So I'll divide the left hand side by delta x equals right hand side divided by delta x. So we've gotten an expression similar to the formula I showed you in the previous slide, but the expression gave us a complex algebraic fraction which we need to resolve into a simpler form. Now in doing that, there are two methods which I'm going to show you, and you're at liberty to pick anyone that suits you. So I'll write out my formula. Now from this right hand side of this algebraic expression, I can pick 2x delta x divided by the denominator, then this symbol plus delta x to the power of 2 divided by the denominator. So delta x divided by delta x is 1. Delta x divided by delta x is 1. So we're left with 2x. Now delta x divided by delta x is 1. Now that delta x, if we divide delta x to the power of 2 by delta x, it will cancel out 1, and we'll be left with 1 delta x. So the right hand side of this algebraic expression reduces to 2x plus delta x. Now the alternative method is this. Looking at the numerator end of this algebraic fraction, delta x is common. So I can factorize delta x, so that 2x delta x divided by delta x, I'll be left with 2x. So I'll write 2x here, and then I write this symbol plus delta x to the power of 2 divided by delta x, I'll be left with delta x. So I'll close my bracket and roll a line, and the denominator is delta x. So at the numerator and denominator end, I have delta x. So delta x divided by delta x is 1. Delta x divided by delta x is 1. So we can see the right hand side of this algebraic fraction has reduced to 2x plus delta x, and the first method also gave us 2x plus delta x. So if we write out our formula, the final resolution of the right hand side of the algebraic fraction is 2x plus delta x. So we can see both methods give us same answer. So you can use anyone that suits you. Therefore, we find the limit as delta x approaches 0, we write out our formula. Of course, we got our answer to be 2x plus delta x. So as delta x approaches 0, we're saying delta x is getting closer and closer to 0. It will eventually be equal to 0. And so our final answer boils down to 2x. Hence, the derivative of f of x equals x to the power of 2 equals 2x. So if you differentiate x to the power of 2 from first principle, the answer is 2x. I do hope you enjoyed our YouTube video. Kindly share and like our YouTube video and subscribe to Victorian STEM so you could get notifications whenever we post any new video online. Thank you.